Good day, my name is Derek Diamond and I am the Chief Architect at a company, PrimeThought Software Solutions. At PrimeThought we develop mine technical software and mapping software in other areas. As such, we've developed survey packages for underground and surface mining, and one particular package we actually host inside Microstation because Microstation is quite popular in the mines in South Africa. So MineModeller runs inside Microstation, and what I did at the install of MineModeller, I gave myself a little icon on top here to open MineModeller. Now when MineModeller opens, it loads a list of known points referred to as pegs in the mining industry. These are known points that are very accurately surveyed to within literally fractions of centimeters to have the ultimate accuracy to prevent accidents and safety incidents in mining. So what we have here is a list of quite a few pegs extracted from a SQL Server database. We have 85,000 pegs in this case here. They can, at the moment, MineModeller supports SQL Server and Oracle as its database of these pegs. Now these pegs can be searched in various ways. So if I want to search for a peg starting with K, I can type in the K and it just brings them to the front. These are the particular pegs I'm interested in. If I want to plot these pegs inside my Microstation environment, I can select some pegs. I can actually zoom to them. They haven't been plotted yet. I can right click here and say plot, and it's going to plot those two pegs for me over here according to specifications I set up for these pegs. So you literally can set them up, the plot parameters here. You can specify, in this case here, I'm displaying the peg ID, this known point ID on the left. We're displaying one circle, size 1 meter, and on the right hand side we are displaying the Z elevation of the peg, so it's underground, and the type of the peg, the code of the peg. So basically one can zoom to and plot these pegs that you have captured in the MineModeller environment. Now these pegs can be captured in many ways. One way is with manual input. In this case here, you can literally import from a file and it will bring them into the MineModeller database stored in your SQL Server or Oracle database on the server. Another option which we do, and it's used a lot in underground mining, is a double setup survey where you set up twice with a total station, take some measurements. You can actually specify, you can capture all the measurements right here inside Microstation. You choose your new peg name. You can read from a survey instrument if you want, and you can populate all your various measurements, your instrument heights, your horizontal angles, your vertical angles, horizontal angles, distances. It will then calculate the peg for you and store it back in the database. So this is very useful for surveyors. They don't have to leave their familiar drafting environment to do the peg survey, and then at the same time they can also see their pegs in the spatial area inside Microstation. Okay, now we do support various methods of calculating these pegs. I mentioned double setup. There's also a double button mechanism where you use two buttons on the sighting instrument, so that for more accuracy you can use a single setup, you can do a polar, and then you can do a line setup as well. Those are more technical survey terms, but the main point is that it is a way for us to capture the pegs measurements and then calculate very accurately the the peg's position and put it into our database for us to use here. Now, further, we can actually, what's been added with MineModeller is we can import data very, very easily into Microstation. Some of the formats are some mining formats, and the mining formats here is DataMine, very mine technical system company, very popular. We read all their formats. Surpac from GeoVia, and Model Maker, a South African surveying package. We can read that data straight into Microstation to be used there as well. We can read CSV files and XYZ files and straight from an instrument by clicking that button over there. We'll come back to an import later. Let's just first look at a very simple survey since we do have two pegs displayed to us on the screen here at the moment. So a typical thing you would do in surveying is offsetting. What you would do with offsetting is you'd first of all pick a start peg. So here we go. I can pick this peg over here. And then I'll pick the end peg, which will be this peg over here. I could also pick them from a drop-down list, but I chose to pick them straight off the screen for simplicity. Now, having chosen that my offsetting is going to be between these two pegs, it effectively lets me put a line between them, or a tape. And then what I can do here is I can say the tape starting at position 0 at the first point, and I can actually extend the tape here to most likely it will go past the end point because it would never be exactly on the end peg, and there would be my tape. Okay, now what I'm able to do, and what the miners and surveyors often do then, is they need to calculate offsets from this tape to the left and to the right along it, which would be measurements usually of pillars or any other mining constructs underground. So for example, over here, maybe I'd say that 5 meters to the left, starting at the beginning of the tape, and 5 meters to the right. There we go, and it draws it in for me, and I can carry on like this. The next could be 4 meters, and maybe this is position 3 meters along the tape, and the right hand side is 3 meters, and there we go. And I can carry on like this, doing offsetting from that tape. The end result of this offsetting, maybe these were two pillars, would be to create points from which I could create pillars. So typically what the surveyor would do, he'd choose here which layer does he want to save those points to. We'll do it to the default layer. We can just type in a new layer name if we wanted. We'll let it go to default, and you just click save, and it's created those points there for me. And typically what the surveyor would do in that case is he would select these points and remove peg selection, and with those points then he might use a tool here. We've got a utility here to make a pillar straight away. There we go, to make a pillar. Our make pillar tool is quite snazzy in one sense. I can show you here. What I'll do is let me draw a typical sequence of points that you could get underground from a long survey. Now, it's pretty obvious to us how to join these points into a line string. However, it might not be obvious to the computer, except we have made it obvious to the computer. If I chose those points that you saw over there, and let me make sure I'm selecting them. There we go, I've chosen those points. If I say make pillar from those, you will see that it pretty faithfully to what I did, except, oops, I selected a point over there. Let me just undo that and make sure I remove any point from this side here. And if I say make pillar, it will do a perfect following exactly as I did it to make a pillar from those points. It's another little feature that we have in Microstation. Okay, so what we can now look at here is that was the offsetting, the drawing a pillar. What we can do is import points to make a surface. So let me get rid of our creations over here. I'll delete them. Let's delete these as well. There we go. Okay, so I mentioned the import export. So we can import, say for example, we want to do a survey of dumps. We can import XYZ points. I have some data here. So what we would do is, so here we've got base points. So let's import those first. When we import them, it lets us specify a projection if needed. It lets us specify which layer it's going to go to. So let's let that go to a layer called base, and we'll just import it straight. And there we go. There our points are. Okay, they're in the layer base. And then we can import points for after stuff is being dumped. So let's do that. We'll call those the tops. And this layer here, we'll make it go to tops. Okay, and it'll import those. And it's quite a few points. So you can see there that was 90,000 points we imported, and those are the tops. So what we can do now, let's make these into surfaces. So what we will do to make sure we select what we want correctly, let's just go to our levels and turn off the display of what we just don't want to work with at the moment. There's our base and our top. So let's work with the base first. You can turn off the pegs. Let's go in there. And we're going to make a surface out of this. Very simple. We just choose our surface creation thing here, create from selection. So we'll call this surface, we'll call it surface base. We also have an option here to limit the length of the triangles, the sides of the triangles, to prevent it making it very, very convex. You can make it less if you want, but we don't really mind here. So I say create the surface, and there you go, it's created my wireframe surface. And that was now for the base. Let's do the same now for the top. Level display, we'll turn off. So let's take away base, and we're going to view tops and base. So there we go, we've just got tops. Let's select all those points, all 90,000, and we are going to make a surface out of this. Okay, this is going to be surface top. And we say create. There we go. And what we'll do is let's just show our levels here, and let's take the points away, so we're left just with the surface, and there you go, there's our surface. Okay, so that's very fine, nothing too special in that, but we do have some nice features now which we can do in addition now. How about let's do some hill shading of the surface. So we have a very nice way to do that. We've got a very general tool here. I'm going to select our surface, maybe just get the other one deselected. What we will do is go into our levels. We will good surface base and surface top. Let's take away surface base. Good. So what we'll do now is let's we've got a nice option here to do contours. Now the contours we do here, we can literally do filled contours which gives a very nice hill shading effect, which I'm going to show you here. So you can choose the direction in which you want to contour. The usual direction is vertical, and that's with Z1 and X and Y 0. I can say compute my parameters of my contours from what's selected. And there you go, it's computing it. It's saying that if I want an interval of 10 meters, I'll have 3 contours. I'll make my contour interval 1. I'll ask it just to recompute here. Now it says I'm going to have 22 contours. And at interval 1, what I'll do here now is I'm going to make filled contours, just because it gives a very nice effect. And we even have an option here to just do a calculation of the contours and give me the results here, which would help you for some sort of volumetrics if you want it, or you can tell it to actually generate the contours in a layer. We will do that, and we'll put it into a layer called contours. There we go, we've done it all, they're filled, and we're telling it to actually color these contours from green low to red high. Okay, we're going to say contour. It's going to go through and do its contouring. There we go. We have a contoured surface. So let's just hide what we don't want to see so we can see our surface. So surface top, we're not interested. We just want contours, and there we go. So there you can see our contours colored per the what we specified. So let's get this to look a little bit prettier. We'll just do a smooth shading of this to get a real idea of how it looks. There we go. And what we can do here is let's rotate this and see what we've created. So there you go. Out of those points, we've created our hill shaded, contoured surface here in Microstation. Okay, very good. So what we'll do here, let's go back to normal. Wireframe. Okay, good. So that's our hill shaded contours. I'm going to hide that layer. And let's do something else with the surface. Let's look at the two surfaces there. See, they're still selected. And we'll view from the top. There we go. All right. So now what we can do, let's do a profile along these two surfaces here. And that's going to be this option here. So what we do with the profile is we choose the line along which we want to do the profile. So it's quite fun to do the two surfaces here. So what we'll do, let's pick the line along which we want to do the profile. Let's do the profile along here. It looks like there's lots of activity going here. So I'm choosing my first point. Good. Let me just do that again. I must choose the start point. And then the second point. Good. There you go. It's got my 2 points. Now we choose the levels or layers we want the profile to be done on. We're going to do it on the surface base. We want the profile, and we want the profile on the surface top. So let's get an idea of what the profile looks like. There we go. So here you can see here on the screen, it's made me a little profile. The surface base is the bottom there, you can see it there, and then the surface top is this one here, and that's a profile along the surface there generated, which you can now copy and put in a report and so on for whatever you want to do. All right, so the next feature we can use or do here is working with these two surfaces. How about doing a cut and fill? It's a common operation in mining, in surface mining in particular. So what we're going to do is let's first isolate our layers here and see what we've got. Okay, we've got surface base and surface top, so let's keep this here, and just to make sure we're going to select the surface top, I'm hiding surface base. I'm going to select surface top, and I'm going to say that's my new surface. I'm going to add that to my cut and fill operation. There you go, it tells me what its area is, and let's put it in. And my base surface is going to be the other one, so we'll just go to surface base and turn off surface top and choose that. There we go. Surface base, so we're going to add that. Aha, it's still got my surface top there, which I don't want. Let me just make sure I deselect it. Okay, let me just fix up my element selection. We're going to remove everything here, make sure there is nothing there, and I'm going to clear the base surfaces just to make sure I don't have an issue. Now I'm going to hide surface top, and now I can choose surface base and add it. There we go. So we've got our base surface and we've got our new surface. There we go. Okay, and now what we can do is we can choose to have a perimeter around which to do the cut and fill. We won't have any. You can specify that you want to break it up into levels. That's a good idea. Let's auto set some levels. Let's make it 10 levels, interval of about 2. So we'll know at each vertical level how much is being cut or filled, which is often useful. And once you've done that, you can just do your calculate. Good. So there you go. There are all my numbers. So at each level, there's the cut and there is the fill. Done for me automatically. There's the total fill, the total cut. And what you can do, you can get a graph of your cut and fill vertically to the right. You can just change it around to make it vertical orientation. So vertically, that is how the cut and fill goes. You can quickly get a profile of it like that. So very quick way to do your volumetrics from those points that we imported. Okay, so playing nicely with those surfaces, let's go on to show you some import of some mine technical data and how we can work with that. So let's bring in a data mine file here, and I'm going to put this on a layer called pit because I know that it's going to be a pit, and we're going to import a string file from data mine. Just browse for it. There you go. Remembered from my last preparation. I'm going to open that up and we'll import it. There we go. So straight away here, with colors preserved and everything, we've brought in a data mine pit design. And what we can do quite nicely in MineModeller is how about making a surface out of this quickly. Okay, so let's do this. So let me first just choose that correctly. So I'm going to select those points there. I'm going to go back in here. Move that out the way. Oops. And we'll go back to surfaces here, and we're going to say create from selection. And we can put it into pit surface. So I didn't select everything. It made it between those two line segments, which is fine. That's what it can do in this case. But anyway, the main point is that we can bring this in and create surfaces as needed, and even bring in mine technical data here. Here's the surface it made just between those two there. Okay, so what we can do here is anything else we can do here. Here's a very nice feature which I'm going to show you, which is used quite a lot in mining, is offline mining calculations. So what I'm going to do here, I'm going to open a file which has already got some planned development and actual development. It's this one here. We're going to now go to our tool here. Just close this. So what typically one does in mining, I've made it a small area. Typically you do it over a huge area, over thousands of pillars. So what happens here is, you can see over here, these are the dotted rectangles are the planned pillars. That's what was planned in the mine plan, but then in the real world we get these particular pillars here. And of particular interest to miners is how far their deviation was from the planned pillars. And even, which is, there are two instances. One is if you mine too much, like they did here, the overmining, you can actually compromise the safety of the mine over here. And in the spot here where you don't mine enough out, you might be wasting and leaving behind material or ore which should be processed. So it's very needed to be able to calculate these kinds of things. So what we can do here, we've got an offline mining tool. What we do is we're going to choose. So if I hover here, you'll see that that dotted thing, it comes from the mining layouts layer. So the actuals, the planned layer is mining layout. I've chosen it here. I can drop down and choose any others, but there I've chosen it there. Then the actual layers is actually these polygons here. If I go in here, and you'll see it comes from the offset pillars layer, which I put over here, offset pillars. I could have chosen any layer I want, but that's the one we're choosing. Good. Now, what this is going to do, it's going to put the overmined result in the layer called over, and the undermined results in a layer called under. Okay. Now at the same time, there are certain safety factors that can be calculated based on geotechnology, rock technology. Basically, it's based upon how the height of the pillars, the pillar center distances, the blast damage depth, and all those sorts. Based on those, there are some safety factors that can be calculated and displayed. So this tool will do that as well for us. So what we've done is we've chosen the planned, the actuals. We choose what we want to work with. We want to do the calculations on those particular pillars over there. And having done that, we can just calculate. And once it's calculated, you can look at the result. Oh, did not calculate. Let me just see. There we go, it's calculated. Okay, so as you can see here, it puts the overmined in red and the undermines in yellow. Automatically calculated those elements for us, put it on those layers for us. And the nice thing is, it's given me a grid here, which shows me, it's per pillar, it shows me how much is overmined, how much is undermined. Obviously, you won't usually have both, but you can, like here. And it gives you some various factors, and it also gives you the Salomon safety factor and the Bunyovsky safety factor for each pillar. This data here you can export straight to Excel or a CSV file, and together with your picture over here as a report. And it put the safety factors, the chosen safety factor, here in the center of each pillar for easy reference. So there you go, a very quick way which could take draftspeople many, many hours, especially when you have thousands of these. In one moment you can calculate them like that with this tool. Okay, so that's really a quick overview of MineModeller and how well it works inside Microstation and allows our mining clients to use their favorite drafting tool and be able to do full underground and surface survey computations in this environment. Thank you very, very much for your time. It was a pleasure doing this demonstration.